So here we have two functions, f of x and g of x, and we want to determine an explicit equation. Again, that means you want an equation with just x's that represents these composite functions, g of f of x. Remember the other notation for g of f of x with the little circle? Just as a reminder of that. Okay. So g of f of x, what that means is first we will put f of x, which is the square root of x, inside of g. And now we're going to put the square root of x inside of g, which will equal square root of x all squared minus 4. Now when we simplify this, what happens when a square root gets squared? It just becomes x, and so we end up with a line. Now we have to be a little bit careful here, because if we were graphing this, x minus 4 would have a y-intercept of minus 4, slope of 1, go up 1 over 1. This is what the graph of x minus 4 is. But we have to be careful with the domain, because what's not allowed? Negative numbers. Because if you put a negative number in the beginning, that first has to go into f of x, and f of x is taking the square root of any number. So we can't have any negative numbers, so our domain is x has to be bigger than or equal to 0. So as far as the graph, we've drawn x minus 4 here, but the actual graph would start at x equals 0 and just include those positive parts. So it wouldn't be the entire line. It would just be the line when x is bigger than or equal to 0. For f of g of x, now we're going to put g of x inside, which is x squared minus 4, and put that inside of f of x. So we replace the x with x squared minus 4, and we get the square root of x squared minus 4. This goes back to chapter 2 if we wanted to graph this. Okay? Are you okay with graphing x squared minus 4? X squared minus 4 would be a parabola moved down 4, as from our transformations unit, and it would look like this. Then going back to chapter 2, how do we graph square root graphs? Or maybe I'll even do it on the same graph. When you're graphing the square root of a graph, what were some important things that we remember? The points that are going to stay the same are 0, because the square root of 0 is 0, and 1. And between 0 and 1, our graph is above, and after 0 to 1, our graph is below. So there's a look at what the square root of x squared minus 4 looks like graphically. When we look at it graphically for that green portion of our graph, we can see that the domain goes from negative infinity up to a certain value, and then starts at another value and goes on forever after that. What are these two values? What are those x-intercepts? Positive and negative 2. So this is looking at it graphically, and from the graph we could say that our domain is x is less than negative 2, less than or equal to negative 2, and x is greater than or equal to 2. Yes? If you would factor inside of here, you could get x squared, x minus 2, and x plus 2. And that would help us also figure out the domain. Let's say you're not good at graphing square root graphs and you're not feeling super confident about this. What we saw at the beginning of this unit is if I have the square root of something, we know that the square root of something has to be a positive number, or bigger than or equal to 0. So if we tried to solve when is x squared minus 4 bigger than or equal to 0? Well, this goes back to grade 11. First of all, if we made it equal to 0 and factored it, you would find out that x is equal to 2 and x is equal to negative 2. And this is where, if you would make your values of where it's true and where it's false, if you would plug in a number less than negative 2, like negative 3, you would get 9 minus 4, which is bigger than 0. This section would be true. Okay, we are going to include these values. This section's going to be false, and this section's going to be true. So we could figure it out that way as well. Because if you plugged in 0, you'd get negative 4, and negative 4 is not bigger than or equal to 0. Yes?
One of those number lines, are the areas always alternating between true and false?
Not necessarily. Especially once, like with parabolas, it does. Because parabolas, as we can see in our graph up above, our parabola always has something above, then something below, then something above. For the most part, there are parabolas that just bounce, right? Then it's going to be true if it's above and true if it's above there, or both false. So that can happen if there's only one solution. It doesn't have to alternate. So I'm going to say no to always just alternating, because it's not always the case. So we could see from the graph that our domain, or we can see from solving it that our domain is x is less than or equal to negative 2, or x is bigger than or equal to 2. In interval notation, you would go from negative infinity to negative 2 and include negative 2, or from 2 to infinity. So you could use either of those notations. Questions you can do for practice are 6A, B, and C, and question 10.